Hey there and welcome. Today, we are going on a really cool journey. We're going to take what looks like just a boring spreadsheet and use the power of Python to find the incredible story that's hiding inside.
So, picture this. Someone hands you a file with, over 1,700 rows of data. You open it up, and it's just this wall of numbers and text about different countries. But buried somewhere in all of that is a really powerful story about global health over the past 50 years. Our mission? We're going to use Python to find it.
All right, so like any good adventure, you need the right gear. And for a data adventure like this one, our very first step is to get our digital toolbox all set up. And the main thing we're going to grab is something called Anaconda. Think of it as the ultimate data science toolbox. Instead of you having to go out and hunt down a dozen different programs one by one, Anaconda bundles everything, Python and all the essential tools we need into one simple installation. It's the perfect starting point.
And honestly, getting this toolbox is super easy. You just head over to the website, download the latest Python 3 version, and run the installer. You know the drill. It's that classic next, finish kind of setup that gets you up and running in just a few minutes. It's designed to be totally painless, so don't let it intimidate you.
Okay, so we've got our toolbox, but where do we actually use all this stuff? Well, that's where our digital workbench comes in.
And that workbench is called a Jupyter Notebook. Now, this isn't just some boring text editor. It's this awesome interactive space where you can write notes to yourself, run a little bit of code, see the result right away, and then write some more notes. It's that amazing mix of your own thoughts and live code that makes it perfect for digging into data.
Now, to get the hang of this notebook, there are really just two modes you need to know about. When you see a blue border around a cell, you're in command mode. That lets you do things to the notebook itself, like add or delete cells. Then you press enter, and that border turns green. Now you're in edit mode, ready to type your code. Just remember, blue is for bossing the notebook around, green is for getting the code in.
And hey, to get you moving like a pro right from the start, here are a few key shortcuts. The big one, the one you'll use all the time, is Shift plus Enter. That's how you run your code. To make new cells, you just hit A for above or B for below when you're in that blue command mode. And if you want to get rid of a cell, just a quick double tap of the D key will do it. Getting these down will make everything feel so much smoother.
All right, our workbench is open, we're all set. Now for the really exciting part. Let's bring our data into the notebook and actually start digging in.
So, first things first, we need a special tool from our toolbox. It's called Pandas. This one line of code, import pandas as PD, is basically like summoning a super smart spreadsheet program right into our notebook. That PD part, that's just a common nickname we give it so we don't have to type out pandas every single time.
Okay, now that we have pandas, we can use it to actually read our data file. With this command, we're telling pandas to read the CSV file named gapminder.csv. Then we're telling it to store everything it finds into a variable we're just going to call df. df is short for data frame, which is just the special pandas name for our new superpowered data table.
So, we ran the code and nothing happened, right? It just went to the next line. Well, the data is loaded. It's just sitting quietly inside that df variable we created. So the obvious first question is, what's actually in there? So how do we actually see it? Easy. There's a super simple command, df.head. This just tells our data frame, hey, show me your head, which means just show me the first 5 rows. It's the perfect way to get a quick look and make sure everything loaded in correctly.
And boom, there it is. We can immediately see all of our columns: country, year, population, continent, life expectancy, and GDP per capita. All of a sudden, what was just a file name is now this clean, organized table right in front of us. Way less scary, right?
Okay, so a 5-row preview is cool, but that's just the tip of the iceberg. We know there's more data than that. So how big is this thing, really?
For that, there's another super easy command, df.shape. This doesn't actually show us the data itself. Instead, it just tells us its shape, its dimensions. It's going to tell us exactly how many rows and how many columns we're dealing with.
And when we run that, we get our answer. 1,704 rows and 6 columns. There they are. Those are the 1,704 data points we were talking about at the very beginning. Now we know exactly the scale of the adventure we're on.
Okay, so we know there are 6 columns. We saw them in that first peek, but what if we just want a quick list of their names? Just to make sure we don't misspell anything when we need to use them later.
Yep, there's a command for that too. It's just
df.columns. And that gives us this nice, clean list of all the column headers. We've got country, year, pop, continent, life expect, and GDP per cap. Perfect.
All right, let's recap. We've got our tools, we've opened our workbench, we've loaded our data, and we've poked around a bit to see what it looks like. Now, it's time for the payoff, the magic.
This is the big question we're going to ask our data, the one that's going to reveal the story. For every single year we have data for, what was the average life expectancy across the entire planet? Did it go up? Did it go down? Let's find out.
And this single line of code is how we get the answer. Now, it might look a little intimidating at first, but let's just read it like a sentence, from left to right. We're telling pandas, first, group by all 1704 rows based on their year. Then, once they're in groups, we only care about the life exp column. And finally, for each of those yearly groups, calculate the mean, which is just the average. It's just so powerful.
And that one line of code gives us this. This is the story that was hidden in all those numbers. In 1952, the average life expectancy around the world was only 49 years old. Fast forward to 1977, and it's up to 62. By 2007, it had climbed all the way to 67. The story wasn't just in the data. The story was the data. We just needed the right tools to let it speak.
Think about what we just did. We went from a random, intimidating data file to a powerful insight about the history of global health. And we did it with just a few simple commands. That is the power you now have. This was one story in one data set. Just imagine all the others out there waiting for you to discover them.